Hey, it's Alex Williams of the New Stack here at KubeCon plus Cloud Native Con in Seattle, and joined today for an interview with Steve Bauer of Bloomberg and my co-host for this discussion, Job Jackson, managing editor of the New Stack. Hey, all.
Hey.
Hey.
Job's been doing a little research, so Job, I'm going to turn this interview over to you, and I'll be there just to ask questions here and there. How about it?
Fantastic. Stephen, thank you so much for taking time to talk with us.
Thanks for having me.
When I think of cloud native, maybe media doesn't come immediately to mind, but Bloomberg, that would make sense because Bloomberg's always been a technologically advanced company. And you guys have been doing a lot with cloud native technologies, at least in your shop, so I hear.
Yep.
Excellent. You've actually been, the CNCF has noted your success in that as well.
Yeah, last, I guess, Copenhagen earlier this year. Yeah.
All right, terrific. So, so let's dive right into it. What brought you to the point of starting to consider Kubernetes and cloud native technologies?
Sure. So the group that I run at Bloomberg, we manage what's called data and analytics infrastructure. So we manage all of our data, like a large swath of our data infrastructure, things like databases, search engines, Hadoop infrastructure, you name it, as well as a whole bunch of different analytic platforms that use those different data services. And what we started realizing, this is probably about 3 years ago, is that go ahead. About 3 years ago that. All of those different services, we had built our own hacked version of what is Kubernetes in order to manage and run those at scale, right? We run hundreds or thousands of instances of, databases like Postgres, MySQL, Solr, a search engine, and so managing those at scale, like thousands of instances of those, you need a system to do that. And so about 3 years ago, we started looking at, we had built a system for ourselves and recognized that it wasn't going to scale to where we wanted it to be. So we started looking at things, out in the ecosystem and looked at all different stuff, and kind of came to Kubernetes really because it actually has this a very similar model to what we built, which is a very declarative model where you declare something should exist, and then something goes and makes it happen, and that's what we had built, and it kind of fit our pattern. I mean, there's lots of other reasons I can go into, but yeah.
But so scalability was an initial concern. I mean, you guys get a lot of bursty demand on the data products.
So on the data products, like bursty is one thing. A lot of these systems themselves don't necessarily burst. You're not going to burst on a Postgres database. You have to move if you have terabytes of data. Nothing bursts at that point. But it's really like in terms of scale, in terms of number of them. So the team that I actually initially built at Fast was to provide search infrastructure to the to the entire company. We now run north of 2,000 Solr clusters. That are tens of nodes each, and so it's more about volume in terms of Bloomberg runs on data. Everything is data, so we being able to provide that fast and accurate access to that data is like critical. So having a system that can scale to grow as more data types, different types of data come in, people want to pivot and move that data in different ways for different use cases and stuff like that.
So this is I guess this is financial data. This is also, it seems like a lot of text. How would you characterize the data and the data usage?
Everything. I just had simple things like if you go to our career site, I'll put a little plug in for ourselves. Our recruiting site, all the job postings. If you go there and search, right, that's running on our search infrastructure. If you go and you start doing bond screening on the Bloomberg terminal, that's using search infrastructure and our databases and our Hadoop infrastructure, and so we have impacts all over the business, and it's financial data, it's news, it's imagery, it's you name it. We have some of it. Excellent. No e-commerce. Thanks.
So were you moving towards, I guess, a microservices sort of style before in terms of keeping everything simple and interoperating everything?
Yeah, I mean, interestingly, Bloomberg, we've had our own, I would say, services architecture for a while now. I mean, Bloomberg has been around since '82, right? So, we've been at this for a while. Obviously, breaking down larger services into smaller services when it makes sense, makes sense, right? But for me, it's not necessarily the act of breaking it down. It's about changing the actual model by which people build and deploy and manage their software, right? So, breaking things down for the sake of breaking things down. I feel like you hear that a lot. Like, I'm going to break everything into microservices, and it's like, what? Okay, do you have a good reason for that? And for me, actually, the reason is, testability. Like we have some services that we use, for example, for like managing how we change configurations in Solar and move data from deployed schemas and configurations into our Solar clusters. We have a service that we built that does nothing but that, and we haven't redeployed it for like 3 years, right? Like to me, that's the value add for a microservice, right? And it changes, so when you can do that and you can say like this thing does one thing, it does it right. I've tested it, it's battle, and that's all it does, and I'm not going to touch it ever. And then when I want to do something different, I can do something different, right? And then thinking about instead of deploying things in the way that you used to deploy them, things like Lambda start getting really interesting when you're like, what we're talking about now is a bunch of dependencies in a runtime, and off you go.
But what's the business reason for making the switch?
Business reason for making the switch. I guess from a purely business perspective, you could look at it to some extent. At least in my world, I look at it from a cost savings perspective, right? And that's probably not like. We don't really look at it like that necessarily internally. Like a lot of these.
But it starts with a business objective, and then the architectures are developed.
Not all the time. Like Bloomberg is an interesting company in that way. Like a lot of this actually is from the bottom up. It was us as engineers looking at how we build and manage. So I started with the search infrastructure team, and other teams kind of came into my organization, and we all realized that we had all built the same system for managing how we deploy our, whether it was Postgres or Solar or whatever, and that by centralizing that into like one consistent platform, and instead of all of us working on that, what the real value add, as I see it, the business value for us is that those people can now focus on the actual tools that they're working on, and we are like a large contributor, for example, into the Solar ecosystem. We have a bunch of committers at Bloomberg. I would rather them spend all of their time doing that than figuring out how to like collect metrics and orchestrate their software across a bunch of servers. Like that's where the business value is for us.
Now, I'm sure we have a lot of listeners who are thinking about Kubernetes, and they're like, well, how do I put it into the enterprise? And what were the first steps for you guys? Was it just a pilot project with one data set, or could you describe that initial pilot?
Yeah. So thinking about like large data systems, like stateful systems on Kubernetes, even today is not necessarily like a done deal in terms of like, is this like a reasonable thing to do at scale, right? Like I think if you're, have all the beauty of being in the cloud and you can have, storage that moves around with your instances and stuff, great. That's not really the game that we're playing. And so what we realized we needed to do is first actually really deeply understand Kubernetes. And so we picked a project we built, we're actually talking about it tomorrow, some folks in my org, about our data science platform, kind of our journey that we took there. And we wanted to start with something stateless, right? So, building a data science platform that would allow us to, analyze and build models and, and so forth. Actually, it was at KubeCon Berlin where we actually realized, like, hey, we could like build this thing and model it using CRDs, and so that was kind of our first foray into Kubernetes.
And that was worth the investment then, the initial investment?
Yeah, I think so, because what it did is it got everyone from the infrastructure guys, SREs, all the way through the developers to actually like it forced them to work together to understand what they were actually building, and I wanted to do that before we even invested in thinking about putting stateful services on Kubernetes, because if they don't know how to deal with it, they don't know how it works, it's just a mystery, right? Like something breaks, like what do you do, right? And for us, if it breaks and I can't have somebody immediately respond and be looking at the source code and be familiar enough with the source code that they can respond to that, it's already too late for us. Like we, if I have to wait 10 minutes for an SLA to call a vendor to hear back and whatever, like I need my guys to be able to fix it right away, right?
Terrific. I was wondering, we mentioned Kubernetes. Are there other CNCF or open source technologies that you rely on?
Yeah, all over the place. I mean, almost everything in my whole organization is built on top of open source. So, things like Spark, right? We actually contributed a lot of the Spark on Kubernetes native scheduling stuff to Spark. We built that. We've done, another guy from Bloomberg is giving me a talk on work we did in integrating Airflow with Kubernetes.
Oh, nice.
And so, whether it's, Solar, we contribute in the Hadoop ecosystem, things like Postgres and MySQL, we obviously use pretty heavily, and as well as we have a number of our own open source. Another guy from Bloomberg is going to talk about a piece of software called Goldpinger, which is like a monitoring tool. Also another tool. Goldpinger.
Like pig.
Yeah.
Goldpinger.
Yeah, exactly.
Okay.
But and another tool that he wrote called Powerful Seal, which is like a Chaos Monkey for Kubernetes.
Wow. Okay.
And so it's both consuming it and putting it out there is really, it's kind of the heart of what we do.
So do you see data streaming architectures feature in Kubernetes and in these cloud native technologies? That's a trend we're starting to see.
Yeah, absolutely. I mean, we have a number of different, whether it's Spark, using things like Spark or Kafka Streams, Kafka Connect. We have a service that we offer internally that's built on top of Kubernetes, custom resources for, standing up Kafka Streams, and, you to give it a jar file, you give it a reference to a jar file or like a Maven artifact, and it pulls it in and off you go, you're streaming. So
comparatively, what's the advantage of that to traditional methods that you have used for data science?
For like
what's the
streaming
upside
in general?
Yeah, use Kubernetes as a mechanism for data streaming.
I mean, I probably the biggest benefit is we built a CRD called Stream Service, and you can kube control apply Stream Service, and you get a Kafka Streams endpoint that starts reading off of whatever topic, right? And a lot of that is the value there is, especially with the CRDs, is about how we bind that to Bloomberg world, like the rest of the, how we do things in our existing workflows. So being able to build that binding and that abstraction to say, I want to go from, some definition at a high level through some sort of auditing system to deploy it down to a CRD that's deployed in production, and being able to manage that kind of at scale just lets us stamp those things out really quickly, and then obviously test them and do all that stuff that happens beforehand. So.
Nice. And so this is a service that at the end of the day goes to the analysts or the reporters within Bloomberg.
For my organization, it goes to other engineering teams.
Okay.
Right. So and then they provide applications and capabilities. So like the org that I run actually is purely focused around providing infrastructure to other teams.
So there's at Bloomberg there's app developers working for the end users within the organization. Your job is to provide the data for the
the data services.
Data services.
Yeah. So no, we don't provide like any data at all ourselves.
Gotcha. Yeah.
So does Bloomberg run its own data centers?
Interesting question. Yeah, we have some stuff in the cloud, but yeah, primarily we're on-prem, and and for a lot of the stuff we're doing is on Metal, so yeah, it's an interesting challenge in the cloud native world.
Is that for financial reasons or for performance reasons, or a little bit of both?
There's a lot of reasons, but from my perspective, a lot of it's around the ability, to, like, a lot of these data systems are running, Solar is a good example. The types of things we're doing with it, if we don't have direct access to SSDs and like large memory footprints and stuff like that, we just can't do the things that we want to do. And so there's some very basic reasons, like if I have a search index that's maybe a couple terabytes of search index, I can memory map that, right? And if I have a half a terabyte of memory on a box, Solar will memory map that all in, in, and I'm just letting the kernel page stuff in and out, which is about the fastest thing you can do. And I can't do that if I cut it up into a whole bunch of little VMs, right? I can't take advantage of that memory space. Even if I added more nodes to my Solar cluster. So
excellent. Well, this is the first year I think at KubeCon we're seeing a big impact from the large enterprise IT vendors, Oracle and VMware specifically.
Sure.
Do you run into the question of whether or not you should consider having an integrator come in and take over large parts of this and let them mess with all the integration, or is it something that's still more efficient? You have more control to do this in-house.
Yeah, I don't think it's. I mean, for us, it's really like that kind of open source first. Like, if it means working with someone because we can't build that skill set, we'd rather build the skill set internally than obviously the scale that we're operating at like allows us to do that. Like if I was selling shoes or something like that, and I had a small IT org, there's you can't spend all your time building the skill set to do that. But for us, the criticality of this infrastructure, this to our infrastructure, and the demands of our customers, we don't want to ever be down. And so, if it means training someone and getting them to understand it, and I also look at that as an opportunity for career growth for people, right?
Right.
Like if you're involved in an open source community, that's like the best way if you want to stay an individual contributor and not manage people or become an architect or something like that, to actually grow yourself, right? I think we had an intern that contributed some code along with one of our folks to Solar a few years back. He was a first-year graduate first-year freshman doing an internship, and started getting job offers after his name's appeared in the Solar commit logs, right?
Oh,
so
okay.
right, like that's just that's a outside example of how the value of actually letting our engineers work in open source and become part of communities and grow themselves.
Excellent. Is it so when you're looking for a new software engineer, what are the skill sets, or what's the mix? Are you just looking sheerly for Solar experts or Kafka experts? Or are you looking for some other qualities that that would be useful for the team?
Yeah, I mean, my org itself and Bloomberg as a whole is so diverse, right? We have Bloomberg participates, for example, in all the C++ standards bodies and things like that. We have a
Really?
huge C++ development community, and we drive a lot of C++ standards from Bloomberg, right? So it's very varied, right? We have quite a lot of people writing Fortran code still because it's really still relevant, and so. But with my org, it's always lovely to find people that are like, I'm an expert in Solar, or I'm an expert with Spark, and I'm going to come in and go do that. And I would love if someone wants to do that. Yeah, give us a call. But actually, most of the people that are working on these things have started out. They're just good software engineers, right? They're maybe a good Java developer. They sat down, started getting involved. They had the time, given the time to actually invest in reading through and understanding source code and working with folks in the community and going to conferences and talking in the hallway and
Sure.
Solar. So Solar's been around for a while.
Yep.
Are you looking at do you ever look at other alternatives to it? And if so, I'm curious what you find interesting out there.
Yeah.
Or conversely, what is it that you find that you enjoy about Solar?
Yeah, I think there are obviously alternatives out there, that are there. For us, the thing that we really like, that I really like about the Solar community, is that if you look at the diversity of contribution and control of the ecosystem, like if you look at committers and PMC members, there isn't a company, right, that is the control mechanism for that, and that's not necessarily the case with other search software that's out there. And so for our perspective, one of the things we did really early on when I first started is we started realizing that people are actually wanting to use Solar for doing screening applications for different types of financial data, and that there was a lack of some features in Solar for doing that. And so we built an analytics engine, essentially like an OLAP engine for Solar, and open sourced it. And it was hugely beneficial for us because we took that and went forward. If I had gone to another a software vendor that had a different perspective on where they were going to take their search engine, I may not have been able to actually get that into the ecosystem.
Nice.
And that's so
terrific. Terrific. Next year we're going to be focusing quite a bit on setting up workflows, production grade workflows for machine learning, deep learning.
Sure.
At this point, it strikes me as there's still a bit of a disconnect. You can create a model, and maybe you'll have a way to push that into production under an app, but there's still that feedback loop that has to be completed.
Right.
Once you start getting real results back, how do you put that back into the research side? And do you have any tips that could help us with that?
I think, I don't know if we've been using the term model development lifecycle, kind of like
Model
SDLC,
development life cycle, okay.
and actually what we're starting to realize is that, I think if you look at ML as a practice, right, it's kind of set aside to some extent from like normal software development.
Yeah.
In the end, it's normal software development, right? And so you can start thinking about model development in like that software ecosystem. Mm-hmm. There's obviously some differences there, but we've actually been really focused on this and how we go from I train something to I select when I hyperparameter tune something. Yeah. I choose which tuning that that has the best fit, and now I want to put that into production. Also, like in more kind of enterprisey world, it's like actually when I do make that change, I have to have some sort of an approval process or a way to back it out, or all those kinds of things that are pretty critical. So it's something that we've been the data science work that we've done on Kubernetes so far, extending that into model serving and stuff like that, so we can build that kind of loop. I think it goes even further than that too, because your data scientists really have this desire to look at like the raw data of like my model fitness over time and drift and things like that. So it's building out all the data systems around, and it's not just one thing; it's a whole bunch of different data systems. Yeah. When you're doing it at scale, it means that you have to build systems at scale to support those types of behaviors.
So I just had a quick question, circling back a little bit to what you were saying about bare metal. What are you seeing are the advantages and disadvantages of bare metal for you as you move into this cloud native? You start to adopt more cloud native technologies.
Yeah. That's an interesting question. I think that there are obvious places like I was describing before, and where it hits a sweet spot. For the ML stuff, the other kind of sweet spot is like dealing with accelerators, so GPUs and FPGAs and things like that, which obviously you can do in virtualized environments. It's not impossible to do that. It's just we find it easier, and I think also by removing that virtualization layer and getting rid of that overhead, I think I don't necessarily see a benefit to it. There's obviously some areas around isolation, and like I know Amazon released the Firecracker and there's gvisor and things like that, which are actually really compelling for lots of different reasons. But the idea of having to cut and slice everything up, when you can manage hardware like you manage VMs, diminishing value, I think, from VMs.
So bare metal as an advantage to it, what do you see as that clear advantage, and as opposed to like Amazon offers Firecracker, right? You're saying there's some value there.
Yeah.
But moving forward with machine learning kind of technologies, are there better architectures out there or are there alternative architectures that you're starting to look at?
In terms of like
beyond virtualized infrastructure or bare metal and into more
or something like that. Yeah, I mean, not currently. Like I think there's a lot of interesting thing going on, like in the accelerator space. Things like Google's TPUs or a number of different vendors out there that are selling purpose-built machine learning hardware. So that's an obvious advantage of the current architecture, is that we can actually experiment with that stuff without having to have like a full stack there. And then obviously AMD has their GPUs, and they're making a lot of investments there. So I mean, there are definitely other architectural things. The ARM thing is interesting. I don't know, it's not there yet for us.
Right.
So. Or power or something like that, which is often another different vector. So. Yeah.
Do you do a lot of taxonomy, or do you not so much prep data and just figure it out at the search and query stage?
and I would say, yeah, it's a
spend a lot of
broad,
time tagging stuff, and I'm thinking, well, do we, do you do stuff ahead of time, or do you just, assume that the search capabilities will make up for a lot of that?
I would say it varies across applications, right? We have a broad array of applications and a broad array of teams that are at different maturity levels, right? And so, we certainly have taxonomies. We have hundreds and hundreds of taxonomies that for all different things that people are using, and but we also have one of the things that we open sourced on the search side is a learning to rank plugin that lets us do basically build ML models to improve relevancy and ranking and stuff like that, specifically to deal with the, we have all these varied data sets that have different levels of quality and tagging and whatever, and we want to present the best results to our users. And anything in between, right? It's pretty varied.
Sounds like something we could use at the new stack.
Oh yeah.
It's open sourced.
So
it's in Solar 7.
A question about your team development, and how are you starting to? Is that changing at all as you adopt more cloud native technologies?
Yeah. I think the thing that I think is changing there is that. I think you always had this division between, you had like networking people, hardware people, system admins, and then you had, engineers, and or maybe you had operators as well in the mix or whatever. And you're starting to see, what I see is, the power of putting in the hands of our developers a lot of the controls for the whole stack, right? And so it also, like, none of this stuff comes for free. So having people that actually understand the stack to be able to decide, like, hey, I'd like to push a network policy in, with my pod along with that, and having the understanding to be able to do that without having to go and say, sysadmin, I need some network policy applied on a box. I think it changes. It means that people need to be a little bit broader than just being like, I'm a Java developer and I only look at Tomcat and like that's my my ecosystem. You have to start thinking broader than that. But it's also really empowering to people when people are like, hey, not just can I deploy software to my servers, but can maybe it would be interesting if we could put software on our switches. Hey, that's an interesting thing. Like, we're not doing anything like that now, but like we've had the conversation like, hey, it would be interesting if we moved that up to the top of the rack rather than on the server. And so it's an interesting it's some interesting changes. And
that's quite a challenge, because on the one hand, I imagine that you want the software developers and engineers to worry only about specific business logic that they're concerned with. But on the other hand, you want to give them all the options for if you want to use this particular hardware configuration. So you have to make that as easy as possible.
Yeah, I think it's different in like the org that I run, because a lot of the software we're running is so closely tied to like the hardware and the network and all that kind of stuff. For our like actual like people building applications on top of our infrastructure, I think the simplification that we can offer is giving those new models like Lambda or kind of that serverless kind of model to them, so that they don't have to think about the rest of that stuff, and that they can apply labels and tagging to things that impact network policy and other things like that, or they don't have to think about it. So I guess probably at two different layers in the organization.
So does your team act as so who are your customers? Are they the people who were mentioning?
Yeah, all other engineers at Bloomberg.
So are you looking at Kubernetes operators at all to try to like provide them with the ability to use the Kubernetes architecture itself?
Yep. And in fact, actually, the talk we're giving tomorrow and the data science stuff that we've built, we actually built that using custom resources. Actually, we built them with third-party resources before custom resources existed, and that's how our whole we give our ML engineers the kube control. We give them the kube API directly, and we obviously protect and permission with our back policy that prevents them from doing things we don't want to. But yeah, CRDs is like all we do.
How do you? So what are you adopting any application management platforms to help manage all that? I mean, we see companies like Nirmata, helping kind of the application lifecycle management through the container technologies themselves. So you can have be able to see kind of. For example, in a company like Nirmata, where they'll provide that kind of that management platform, so you can watch the containers as they go through that life cycle. As the applications are used, it goes
Yeah.
back to kind of like life cycle management,
Right.
approaches. We're starting to see it emerge in, where these enterprise platforms are serving as kind of a life cycle management environment.
Right. Yeah, I mean, we have been not. We've been looking at building out like this life cycle management stuff, or so we haven't looked at anything commercial per se in terms of that broad scope thing, but looking at different life cycle managers for different things, like there's of course like all kinds of operators and things like that for Postgres and MySQL and Cassandra and things like that. We haven't looked kind of holistically to say like, do we want to have like a single way of approaching that? I don't know if that's necessarily like a bet that we would want to make, that one group is going to solve all of our problems. We also, like, for us, we want to be involved in that because we're going to have weird use cases and weird things that like a lot of people won't have necessarily, especially around working on Metal. This is one of the biggest challenges in like this cloud native world, as you go and talk to somebody and you say, hey, your software sounds interesting, let's check it out, and then like it doesn't have proxy support, so it doesn't work when you're air gapped, right? And then you're like, okay, we can't even eval your software because you didn't think about this thing that and so and we also kind of try to focus open source first because we want to be part of that, to be able to fix it and become part of that community so we can have an impact on where it goes, rather than just saying like, I pay you a bunch of money, please do the thing I want you to do.
I just have a last question about operators, and we had a discussion earlier about operators and how operators are, can at some point the question becomes is like, do the operators talk to the operators? So you start having kind of these more declarative environments that almost are serverless. Is that an approach you're looking at?
Well, yeah, that's actually how, like, in our data science platform, we have something we call like TensorFlow job, right? Which is essentially a TensorFlow workload that runs. Well, if you want to hyperparameter tune across a wide array of parameters, what you do is you provide a TensorFlow job to a hyperparameter tune job as like as an input to that job as part of its specs. And so you say hyperparameter tune job that, and we have other types of job for running Spark workloads or Scala or Java, other types of workloads, and they're just composable together. So you can say now I want to hyperparameter tune my Spark job. Like, that's an interesting thing that like people were like, wow, I can do that, and it just plugs in and it just goes and scales out and generates the custom resources and everything like that. So yeah, absolutely. Like that composability is like, I think, key to lots and lots of what we're going to be doing in the future.
Well, excellent. Well, thank you so much for your time, Steve.
Sure.
Appreciate it.
Yeah, thanks.
Yeah.
Good stuff.
Thanks for having me.
And Job, thanks for joining and directing the conversation here. We thank you for your perspectives, and we're talking a lot more about operators, I think, over the next several months. So we look forward to keeping in touch.
For sure. Thanks for having me.